Welcome to the TechArena Great Debates. My name's Allyson Klein, and today the Googler's in the house with me. I'm so excited. I've got Amber Huffman and Jeff Andersen from Google. Amber and Jeff, why don't you go ahead and introduce yourselves?
Thanks so much for having us, Allison. Really excited to talk with you today. So Amber Huffman, I'm at Google Cloud, where I lead our ecosystem and standards. I'm the Open Compute Project board member for Google, and I also lead NVM Express.
Awesome.
Hi, I'm Jeff Andersen. I've been working at Google for about 9 years now, working on platform attestation, low-level hardware roots of trust. I'm involved in the OCP security project, where I'm a co-lead, and the data center work group in TCG as well. Worked in DMTF for some of their standards as well. So excited to talk about some of the new stuff we're cooking up.
And I can't wait to get into it. Today's topic is about a new initiative coming from OCP LOCK, and we'll get to that in a second, but let's just talk context. One of the biggest challenges for data center infrastructure management is reuse of devices within decommission. Why is this such a challenge, especially when you can start considering drives?
Yeah, I could kick it off. Great question. So, as an industry, our top priority is always protecting users' data, and that's really at the core of everything we do. It's how we build and maintain that trust. And so, one thing that Jeff's an expert in is we encrypt drives based on the best security practices and algorithms. Now, one of the challenges is we would love to share those encrypted drives and erase all that data and be able to share it in a secondary market and get a second use out of a drive.
Mhm.
But there's a couple problems. One is the first challenge, even if you could go share a fully encrypted drive, you could still have nation state actors that could have resources and potentially break that encryption, which is a big problem. The second issue is, technology evolves over time, and you could have, break older encryption algorithms. So one of the things we've done is how do we think about that we can attestably prove that something is completely erased. And that's where we have not had a mechanism today, especially with SSDs in the industry. And that's where lock is trying to come in.
That's awesome. Now, if we were able to solve this, let's just talk about this from a value chain perspective. If we're able to solve the challenges that you've laid out, what is the opportunity for the value chain in that second use?
So the big opportunity in the value chain is that we could get much better use of, and rather than take SSDs that we no longer have a use for, whether it's at a hyperscaler or in some other small business, rather than crushing those devices, rather you could actually put them out for sale in a secondary use case and be completely secure that you're not leaking anyone's data. And so we would like to have a great opportunity to have the best of both worlds, where you are both secure and you also could be sustainable. So that's really where lock is coming in.
I love that. I mean, you think about drives are advancing all the time. We're seeing higher capacities, higher performance, but just because it's not maybe perfect for a data center or an AI application doesn't mean that that drive couldn't be used somewhere else at the edge. I love it, and OCP is tackling it with lock. What is lock, and why did you decide to focus here?
Yeah, Jeff, do you want to take that one?
Yeah, sure. So this builds on something called Calyptra, which many might be familiar with, but it's an open source hardware root of trust. This is more than a specification; it's an actual implementation. It's RTL, it's ROM, it's firmware, it's a whole tool chain for getting this foundational security into silicon. And what we found is that yes, there are plenty of specifications out there, but implementation quality varies widely. And to do our due diligence for our customers requires us to look carefully at the implementations that we take in. It's more scalable for us to be able to write down and to actually implement, here's what we want to see, and then have our vendors integrate it into their products. So that's what Calyptra is, and it's essentially a root of trust for everyone. It handles identity and attestation, which is a core component of many pieces of secure hardware. But by its nature, it is very generic. OCP Lock is building on that. We are essentially adding new features to Calyptra, specifically intended for storage devices. So if you take Calyptra, flip on the lock switch and put it in a storage device, that's what we're going for. This is also, it involves other efforts as well, because some of the new features we're talking about, like the attested sanitization, some other aspects such as like multi-party authorization, require new APIs for the host. So we're also involved in the standards bodies which govern that, like TCG. So what is Lock? It is a bit of an umbrella effort to deliver hardware for our vendors, as well as defining new APIs for the host and infrastructure to integrate with these devices when they come in.
Now, obviously, we've talked about this as being run out of a project within OCP. Let's unpack that a little bit. Why is this a great thing for OCP to take on, and how does it fit into the broader objectives of the organization? And can you talk a little bit about the project itself and who's contributing?
Sure. I mean, the spirit of OCP is we have large data center customers and we have many vendors, and it is much more scalable for everyone to agree on what their requirements are. So we can just build one thing and integrate it well. So that's very much in line with the spirit of Lock. We have, like, Google is not special in what we want out of our storage devices. Everyone wants more secure encryption in their drives. So that creates a really nice environment where we can partner with some of our other peers in the industry, like Microsoft, and drive this new standard. We also have partners in Samsung, Kioxia, and Solidigm are other core contributors to this. And we're seeing other uptake, much more interest across a wide variety of vendors as well. So we're looking forward to engaging with the industry on this.
And we were
Now,
also taking advantage of the wonderfulness of Calyptra. So Calyptra followed that path before. So a few years ago, Calyptra started OCP and did their implementation at Chips Alliance and established that as a foundation. And Lock is taking advantage of that same proven trajectory. And we're really excited to be on that journey.
Now, obviously, this improves security, or you wouldn't be spending time on it. But actually, can you walk us through how Lock enhances data security compared to traditional methods, and why this is better?
Sure. So how does Lock improve security? Well, one, it's a known good implementation of the lowest layers. So like in a drive that takes Calyptra and takes Lock, only the components that we've actually authored get to ever see the media key. We get to implement the cryptography that mixes that key, or that binds that key to external access keys, and that also binds it to secrets which we can securely erase and attest to. So if you take Lock and you integrate it correctly, then as a cloud service provider, I can be fairly confident that when I provision this drive with an access key, that without that access key, the drive data cannot be accessed. And that when I tell that drive to go erase itself, and then it reports back clean, that it in fact has been cleansed.
And if I double click into a couple things that Jeff just said, to expand a little more, one thing that Lock is doing is multi-party authorization. And just to explain that a little more, what that's doing is traditionally a drive has a single key. And what Lock is doing is giving multiple keys. And so if somebody steals a drive, you still have to go, it's not a single password that unlocks that drive. There's an additional password and potentially from the cloud service provider or whoever is the owner. And then even if you're in a cloud service provider context, there's yet another password that could be from the end customer that owns the VM. And that provides you an ability that even at the end customer, you can say, hey, I don't want anybody to have access to this anymore. And that just gives you an additional level of protection against it being stolen. And then, of course, with the implementation approach, you're looking at the tried and true, what we've seen over the last 30 years with open source. Open source, the more eyes, the more ability all of us can do to make sure we harden these implementations. And so we're really excited about the way that Lock takes advantage of that. And it just layers on the additional security we've been doing at OCP overall. Like if we think about OCP Safe, that's a centralized audit capability and program. And so we're just trying to up the level of game across the industry on security, especially in the storage space.
Well, and it makes sense because this is not an area where any particular cloud service provider is going to differentiate. It's just a core capability that everybody needs and wants to be as good as possible. Um, One thing that I wanted to ask you about is how lock improves upon existing practices like drive destruction or multi-pass overwrites, particularly when you're considering something like operational efficiency and e-waste considerations within an organization. Have you talked about that within the project?
We have discussed, yes. So traditional overpass, requires you to write over every bit of the drive. And we do this in cases where we don't trust the drive's onboard cryptography to erase a key correctly. It takes a long time. It's failure prone. So we'd rather move towards the crypto erase, but we can only do that if we've done our due diligence and ensure that the drive is actually mixing keys correctly.
So basically what lock is providing is a way to do that and eliminating the requirement for something like multi-pass overwrite.
Exactly. Yes. And other improvements we're doing here is, post quantum is all the rage these days. And now, when we're talking about symmetric encryption instead of drive, generally the algorithms in use today are stable, are okay. Like a quantum computer is not going to be able to crack AES 256. But one thing that we are adding in lock when we talk about these multi-party authorization and these external access keys is transport encryption, lightweight transport encryption, so that we can ensure that you can hold an access key in a remote key management service or even an HSM and provision it to the drive directly when it needs it, without actually trusting the host to see that key and to not disclose it. This gives us even more confidence that no matter how the host is behaving, if you withhold access to that, if you withhold that access key, the media on the drive cannot be decrypted. Now, this relies on asymmetric cryptography, which is susceptible to quantum attacks. And so that's why we're targeting post-quantum security from day one. We have two different flavors of provisioning these keys, one based on elliptic curve and another that's hybridized between elliptic curve and the new ML-Chem algorithm.
That's very cool. That's very cool. Now you've talked about Calyptra. You also have something in lock called Key Management Block, or KMB. Can you explain the relative roles of these technologies in lock?
Sure. So Calyptra provides this baseline identity and attestation primitive support. So there is going to be more software on a drive controller than what runs inside Calyptra. And Calyptra's job is to go collect measurements for measurements of that code and then can attest to it. So whenever you're talking to a drive, you can know that you're talking to the right drive with the right firmware. KMB is our name for the new functionality inside Calyptra, which will actually handle these media keys and the access keys and the erasable keys and fuses. So that's just the logical partition. Now, KMB will only be there if you enable lock features at integration time. So if you integrate Calyptra in like an accelerator or a CPU, don't have to add lock, it won't be there.
Okay, got it. Now, Amber, you started talking about open source and the benefit of open source, but when you think about Lock's open source approach, is there anything unique here that you'd seen based on all of your broad work in industry efforts in what the team is doing here with Lock that you'd want to call out?
Yeah, what I'd like to call out is the way that open source software is shifting towards open source hardware. And so if we see Calyptra, it's really the first broad open source hardware approach that's taken by major vendors collaborating and competitors collaborating together. What you see with OCP Lock building on that, it's expanding into the storage space. And I think what we increasingly will find is these functions that are not differentiators, how can we basically harden those and reduce that toil and all be much more confident. So I think that's where increasingly I'm hoping to see as we keep moving forward that more IP blocks that are not differentiating, how can we all leverage them? Because, if we think about what open source software has done, a lot of the types of attacks that you see with buffer overflows and that type of stuff has been solved in lots of cases by by protective languages like Rust and other things. So how do we bring these techniques and open source capabilities to hardware more and more? And we're excited to see the vendors be receptive and how we move forward. And this is just, there's been some talk of NVMe in this, but actually what Jeff and other architects at Microsoft and Samsung and Kioxia and Solidigm have been doing is making sure that everything we do actually applies to any storage device. And so there's nothing that we're doing in here that couldn't be applied to hard drives, or who knows what next generation storage device will come up with in the future.
You know, I was at OCP Dublin, and it was interesting to see how many conversations were focused on memory and storage innovation and what was needed for that next wave of technology. Is Lock a reflection of a deeper engagement with the storage and memory industry in OCP, and what's driving that?
That's a great question. So I think that one thing that Lock is showing, so today you have NVM Express as a standards body, you have many different standards bodies. What I'm seeing is a great opportunity at OCP and that deeper engagement with the storage industry is that things are moving much faster, especially with AI on a yearly beat rate. And we're needing to innovate faster. And typically a standard will take 18 months, 24 months, whatnot in a traditional standards body. What OCP is allowing us to do is come together with people that are ready to move quickly and solve a problem quickly and get to say, maybe it would be only 90% good enough in a traditional standards body in terms of every I is dotted and T is crossed, but you move much more quickly. And then the implementation approach with that Calyptra innovated is really helpful because as Jeff was pointing out earlier, a lot of times these issues come up where people interpret the spec incorrectly. And so by having that full implementation, that is where the rubber meets the road of people seeing that's how it happens. So I do believe that you'll see more and more of how do we just move quickly together and have proven implementations and move forward, and that will move us all forward much more quickly.
Now, let's just imagine a world where Lock is fully implemented. How do you imagine utilization of SSTs to change? What's the impact of vendors, operators? And, you know, where I go is sustainability objectives in terms of reuse.
I'm hoping that as Lock gets fully implemented, that it becomes really boring to vendors because it is going to be like an IP block that you just pick up from an IP vendor, but it's just going to happen to be this community implementation that this becomes an area where people are trying to not, you know, if there's an innovation, it's an innovation as a community to lift all boats. And so I think that's really exciting, and it will be very exciting to have more SSDs and other storage devices available in the secondary market versus any type of e-waste and crushing of those devices. I mean, what you see today that is a big problem, especially with NAND flash, is the algorithms that you use in order to do bad blocks and other things make it so that it's really hard of what you were mentioning earlier, Allison, of kind of override or other things. You just don't have access to all of the NAND on the device. So these types of mechanisms are going to just be a game changer of a lot of times today, you're often like with OCP Safe, you're saying, hey, can I audit your code and really understand why it's secure? Why do I have to trust it? All of that overhead is stuff that we won't really have to do in certain blocks that are proven. So I think it's just a much simpler, trustworthy world as we move forward. Jeff, and any thoughts that you have?
One thing that I did want to like comment on for the benefit of open source here is that one thing that we're targeting is FIPS compliance, for example. This is just an example of why open source is great. It's because we're targeting FIPS compliance. FIPS requirements can be obtuse and onerous sometimes. And we've already seen where the open source nature of the project has solicited input from others, where we've been able to crowdsource understanding of FIPS and identify areas where, oh, okay, it looks like we were about to do something that is reasonable cryptographically, but won't line up with FIPS. So let's course correct. And we can course correct early and make sure that there will be no surprises later on. And so that will further reduce the risk for vendors that want to take this.
So when we look at that end goal, and it is so clear as to what the value is. What's the roadmap for Lock's future development and adoption to get to that vision?
The roadmap to adoption of Lock is, well, we have to make it real first. It's hard to tell vendors take this when it's still, being assembled in flight. So we are developing it on a schedule because we do have intended silicon intercepts. But yeah, so there's the baseline Calyptra platform where 2.0 has recently been tagged for release, and that includes some post-quantum algorithms like MLDSA. What we need then there'll be a 2.1, which will have the rest of the Lock features. So it'll include ML-Chem support and a few other enhancements to the key management hardware. Then we'll implement the firmware for Lock, and then we'll also provide artifacts for FIPS compliance. We need extensive documentation so that vendors who take Lock will have a very easy path towards FIPS certifying or FIPS validating their parts.
That's awesome.
Yeah.
And people can get the OCP Lock 0.8 specification today, download it. The 1.0 is going to come out later this, our target is later this summer to fall. So definitely ahead of the OCP October Global Summit. And Calyptra 2.1 is the intercept for the OCP Lock functionality. And from an RTL perspective, that should be in place. The schedule is this summer as well. So with that RTL done, obviously we can't speak to vendor schedules, but hopefully, knock on wood, they'll be picking this up in their in-flight designs.
That's awesome. And one of the things that I was thinking about when you were going through that, Amber, is that I'm sure there are people online that want to get involved because you've got a who's who of folks working on this together. But one of the nice things about OCP is that anybody that wants to can join the work group and get engaged in the process. So how do folks get involved in the effort, and what would you suggest in terms of finding out more and learning more about where the specification is and where it's going?
Yeah, I think that's the beauty of, as you point out, Allyson, about OCP is things are open. So I would say people should go ahead and check out that 0.88 spec that's out there. Provide feedback. We actually have we'll include in the notes the email address for getting feedback to people like Jeff that actually provide and collate. Jeff's been amazing of collating all the different feedback and diagnosing it, because some of these acronyms from the security point of view, I just my eyes start to glaze over. But there's also Chips Alliance. So Chips Alliance is also an open ecosystem that people can go check out the implementation as well. And so we'll make sure for the podcast notes that there's links to both of those.
That's awesome. Well, thank you, both of you, for being here. I know that you have a lot of important work on your plates on a daily basis, and it was great to learn a little bit more about OCP Lock and how it's going to be influencing the storage arena. Of course, for those who are listening online, check out OCP at their website. You can find all the information about this and other work groups, and then obviously TechArena.ai for more about what's going on in the data center and AI arena. Thank you so much for being here, guys.
Thank you.
Thanks for having us.